Hello friends, this is lesson 19 and here still we are talking about supervised machine learning, and under supervised machine learning we are going to talk about decision tree and how to build the decision tree, and we'll talk about the matrix of decision tree, and then we'll give some examples for them. Now let's start with the first topic. What is decision tree? So decision tree is a supervised model. So when we say supervised model, it means it needs some labeled data. The predictors or features are labeled, then based on that the output or the outcome will be predicted, and the outcome is also in the form of discrete values. So now that can be that can either perform regression or classification. It is used for both the types of classifications. It may be regression, continuous responses, or classification with discrete values or discrete responses. So if it is predicting regression or continuous responses, so that is called regression tree. If it is predicting classification responses, so that is called decision tree, or it is also called as a classification tree. So how it works? It is working based on divide and conquer paradigm. So divide and conquer means first it is dividing or splitting the data, and after that it is then taking the decision. It has to go to left of the tree or it has to go to the right of the tree. So it may be a condition. First it is splitting and then it is taking the decision whether to go to the left of the tree or the right of the tree. Now let's see the structure of the tree here. Decision tree, the structure. So as the name suggests here, it is a tree. So if it is a tree, so it means it has root, leaves, and it has branches. Now let's see what is the root of the tree. So the root of the tree is nothing but the topmost node or feature which has been selected. So the topmost feature or node is called the root of the tree, and how it should be selected, that we'll talk later, but the topmost node is called the root of the tree. And then the leaves are there. The leaves are nothing but the child nodes containing the criteria to be answered. So here we have the criteria and conditions, and that should be answered, and based on the answer it is taking decision to left and right. Then we have the branches. So the branches are nothing but the links which connect the nodes and indicate the flow of question to the answer. Now let's see how to build a decision tree. So for that we have to calculate the purity of data. The data should be homogeneous data. It means the tree has to divide or split the data in such a way that all the homogeneous data should be in one side and another homogeneous data should go to another side. It means all the true values should go to one side of the tree and all false values should go to the other side of the tree. So that is called purity of data. Means all the data is purified, all the true values are separated from false values, or all yes values are separated from all no's values. So they are separated and they are divided into two parts. Some of them went to the left of the tree and some of them will go to the right of the tree. So that is called the purity of data. So how it is done? Select a candidate, means a feature, and then split it. After that calculate the purity of the data, and after the split we are calculating the purity of data. How we calculate that I will discuss here, but it has to be calculated the purity, and after the purity the decision will be taken. So repeat all this will be repeated for all the variables. How many columns we have? For all the columns these steps are repeated. It means we calculate the purity of data, then we take a candidate and split it, and then again we calculate the purity after the split, and this is repeated for all the variables. How we can choose the root of the tree, and for that choose the variable with the greatest increase in purity. the maximum of purity which has any variable, that should be selected as a root of the tree. Now here we have repeat for each split until some stop criteria is met. So it will be repeated for all the variables until some conditions is it stops, or the condition is wrong, then it is not continuing. So until that time it will be splitting and dividing the values. Now these are the metrics, friends. How to calculate the impurity of split? So for that we have the predictors, means the inputs, or we can say they are the features, or we can say the inputs or the data which is given to the model. So splitting by the criteria, these predictors or features or inputs which are given to the model, they are splitting by some criteria. So the criteria should be selected properly, otherwise the data may not be purely classified into groups. So we have the following metrics for that, for calculating the impurity. The first one is called the Gini index, or Gini index we can say, which ranges from 0 to 1. And another one, here we have the entropy, and it is also called as information gain. And the last metric here what we have is MSC. So MSC means MSC, mean square error. So mean square error, if you remember, this is a type of error when we have continuous responses. For that we were calculating this. So it means if we have a regression tree, so we will be calculating this type of error, and based on minimum type of error or rate of this error, the data will be splitted, or the features will be splitted. And this is for regression tree. But these two are for decision tree, whether we will be calculating Gini index or we will be calculating the entropy. Now if you are calculating, what is the formula? Here we have 1 and then summation of pi square, where I ranges from 1 to the class. Class means the feature what is selected there. So until that it will be finding the summation 1 minus the summation of that. We have to this is the probability of I, and I ranges from 1 to the class. So it will be calculating the summation for all, and it will be returning a value. After the value, if the maximum of this will be selected as a root. So if you are using this entropy for calculation, or impurity of split, so here the formula changes. We have minus summation of pj log. Here the log is used. Then again we have pj, where j ranges from 1 to c. This you have to remember, friends. So these two metrics can be used. We will be using the first one for calculating the impurity of split. Now let's see here practically how can we see all these things. So we talked about decision tree. We say decision tree is a supervised model that can either perform regression or classification. If it is regression, so it is called regression tree, or if it is classification, then it is called decision tree. So it works based on divide and conquer paradigm, as we discussed earlier. So now this is an example, friends. So the example is like here we have, let me first tell you about this table. So we have these features, like we have outlook, then the second feature is temperature, then humidity is there, then wind, and this is the response value. So how many inputs are there? 4 inputs, or 4 features, predictors, and this one is called the output or response value, or we can say the result is this one. So based on these features we can predict the output. We can predict the output. So for example, if we go for outlook here, it is raining, it may be raining, or it may be overcast, sunny, like that, and based on that we have yes and no questions here, yes, no, like that. We have to decide whether to play the cricket or any game or not. So here see, this is the tree of that. So we have the outlook, we will see whether it is sunny, overcast or rainy. If it is sunny, again we have to check the humidity. If the humidity is high, then we cannot play the cricket. If it is normal, then we can play cricket or the game. But overcast, if it is overcast, it is alright, we can go and play. If it is raining, again we see whether the wind is strong or weak. If the wind is strong, then again no. If the wind is weak, then again yes is there, we can play. And we say impurity of data can be calculated through Gini index, this one, or we can use entropy, and this is the formula for that, and this is the formula for Gini index. And MSC, this one is used in regression trees. Now let me calculate, you will better understand here. If we consider only the first feature means the outlook. This is the first feature. We are considering this, how many values are there, and we are counting the number of values we have. Okay, rainy, we have sunny, overcast and rainy. Now let's see the output or the response value for them. If it is rainy, how many no's are there and how many yeses are there? If it is overcast, how many yeses are there and how many no's are there? In the same way for sunny, how many yeses are there and how many no's are there? So if we go to the sunny, how many yeses we have? Okay, we have 3 sunny here, and for that 1 is no, 2 we have yes, and again the last one is yes. Then it means 3 yeses and we have only 1 no. So the total number becomes 4. The same way overcast, we have 2 yeses and 0 no's. If we go to rainy, and the rainy again we have here how many? 1 no and 2 no's we have here, it means 3 no's, and we have 1 yes here, 1 yes and 3 no's, and this is also the sum of no's, the sum of yeses, and these are the sum of sunnies for yes, sunny for no, overcast and rainy, like that. Now how to calculate the Gini index? This one. So the formula is given for us here. It is very simple. You just put the values within this formula. So we have Gini index, and then we have play the output. This one is response value, and then we will taking the first, this one, the first feature. And the first feature, what is the value for that? The value for that is, let's first calculate for the sunny. How many values are there? 3 values we have: rainy, overcast and sunny. Now we are calculating the sunny. So based on the formula we have 1, and then we have to calculate the probability of this one. We have to find probability of yes, probability of no, and then that will show us the Gini index for sunny. So 1 minus, how many yeses we have? 3 yeses over total. If you remember the probability of an event whenever we were finding, so favorable numbers divided by total number of observations. So total number is 4, favorable numbers are 3, so 3 divided by 4 according to formula square minus. So this is minus, if you are multiplying within this bracket, so this also become minus. So we have 1 number of no's, 1 by 4. So if you are calculating this, we will be getting 0. This value. If you remember earlier we said Gini ranges from 0 to 1, so the values will be between 0 and 1. And now let's go and calculate the second feature here, the second value of the first feature. Again play outlook if it is equal to overcast. So we have 1, how many yeses are there? 2 yeses divided by 2, total number is 2, and again 0. If you are calculating this, so the result will be 0. Then let's go and calculate the rainy. The rainy again 1 minus 1 by 4, this one yes, then again 3 by 4 the number of no's, and that becomes this much. Now we have to calculate the weighted index also. This is called the weighted index, the Gini index of outlook, which is also called the child node, the total. How it will be calculated? So this total number what we have here, yeah, this one, which is 4 divided by 10 into its probability of the first one. Then again we have here 2 divided by total number, what is 10 here, and into its probability, and then we go to the last one, rainy, which is 4 divided by 10 total number, and it is multiplied by this number. So this gives us the weighted index, or we can call it as Gini index of outlook. So if you calculate that, so the result will be 0.3. Now we have to calculate another thing which is called Gini gain. So Gini gain is nothing but what we are going to do, Gini of the parent node minus Gini of the child node. What does it mean here? So it is equal to the same formula we are applying here, 1 minus, so total number of yeses, which is 6, and number of observations, what do we have? It is 10. So according to formula you square that, minus the number of no's, this one, divided by 10 number of observations whole square, minus, as we calculated here, Gini for child node, and it is equal to 0.3. If you are calculating this, simplifying, and after that we will be getting how much? 0.18. This is the value. So this is the value for the first feature. Friends, you have to remember this. This is for the first feature. And again, the same procedure will be applied. The machine is calculating all for all the features. Say second time it will be taking the temperature. How many values we have for temperature? We have hot, then we have the second one which is called mild, then we have cool. So again, how many yeses for hot is there, how many yeses for mild is there, and how many yeses we have for cool. In the same procedure you apply for all that. And then you go to for humidity. In humidity we have high, normal, again we have high, you put high and normal, and then see the number of yeses for that and number of no's for that, and calculate the same procedure you apply. And then you go for wind, and for wind again you apply the same thing. And after calculating all that and getting this Gini index, the last one, then among those values, so this is only for outlook, you calculate for temperature, you calculate for humidity, and you calculate for wind, and after that you take the decision which one is the largest number. According to this, as we said here, we have to take the greatest number here, the greatest in increase impurity we have to take, so that we have to find for all. And for all here, if you calculate, so the outlook value is greater from all of them, so this outlook will be selected as a root. I hope you understood the procedure, friends. So for each and every you have, the machine is doing, if you are manually calculating, so this is the procedure. If you are using machine learning, so machine learning will be doing the same procedure for each and every feature like this. I calculated only for outlook, you calculate for temp, you calculate for humidity, and you calculate the for wind. The same, you find the Gini gain, and after that you compare all the values. Among all the values you select the greatest as a root. That will be selected as a root, and the remaining again it will be splitted into two, right and left. And one thing you have to remember, friends, here in impurity, the data, if the data is 50-50 divided, it means all the yeses are shifted to left of the 3 and all the no's are shifted to the right of the 3. Here the Gini index will be 0. If the Gini index for that is 0, it means that is the best split. But if the data is splitted in such a way that 50 no's plus 50 yeses are on the left of the 3, 50 yeses and 50 no's are shift to the right of the 3, so it is 50-50%. 50-50, it means the data is not homogeneous, it has mixture. So if it is mixture, so that is the worst case. So there you have to again change the condition maybe was not true, so based on that the data is not splitted correctly. If the data is correctly splitted, it means all the same values will be shifted to one side and all other same values will be shifted to the other side. Then the Gini index for that will be 0, and that is the best case. Now let's see an example here, friends. This is the examples what we talked in the early lectures. Also we have the emails, and within the emails we have to check whether the email is spam or ham. So for that I am using here pandas, and through the pandas I am reading the data set, and here I am dropping the null values from it because it makes some problems while we are calculating them. So let me execute this part. So we have label, the label is either ham or spam, and then we have the messages. So the system should decide whether the message is a ham or the message is a spam. One thing you have to remember, friends, here, see, if this each and every word should be splitted, and for them a column will be created, then you think how many columns will be there. For example, for go, one column will be created, for until another column will be created, for this one another. How many columns will be there? You count like that. See how many rows we have here. 5,572 rows we have, and now we have how many columns? 2 columns are there. But after splitting this, the number of columns will be so much, and because for each and every word it is creating a separate column, and the same words, for example, the, it will be a column for this the, and how many das we have, and that number should be written for this. Maybe 500 das we have, articles the, for that we have 500. So it means the word is repeated how many times? 500 times. This one how many times? This one how many times? Each and every word will be counted, and then they will be tokenized, and then they will be vectorized. If you remember, in last lecture we talked about this. So now let's see and create the decision tree. How to create the decision tree, and how to split, and how to calculate the accuracy of the model. It is the same as what we discussed in earlier lectures. So again, the same procedure we are using here, scikit-learn, and from scikit-learn I say tree, and from tree I say you take the decision tree classifier. So we have to split the data into training and testing, and then see here we are using vectorizer because the data is in the form of text, and for each and every text here word a separate column will be created, and after that they have to be numberized and they have to be encoded, because the model knows only quantitative values, not qualitative values. So that is why we are converting them to some numbers, and that is called, if you remember, feature extraction. So here we say okay, x training, y training, x test and y test we have here, and this function we are calling, and through this function we are providing the message, and then we have the email, which is label. The label is either ham or we have spam, and randomly they will be selected, and then we are using vectorizer here, and I am instantiating that, and then we are feeding, and this is x train value we are feeding and transformed to the matrix. In document term matrix it will be converted to that, and then we are converting also the second thing, which is nothing but x test, and now I am calling in creating or instantiating an object for our classifier here, and we say max depth is equal to max depth of the tree is equal to 3. It means 3 questions will be asked there, the conditions 3 times, or 3 important questions will be asked, and based on that 3 questions the tree will take the decision whether the value should go to left or right of the tree. So this is randomly the data will be selected, we said yes, and then we are feeding the data to the model, training data. So this is vectorized data, and this is y train of that, and here we are predicting okay, here this is x value, and through x value we are predicting here the y value, and now let me execute and print here, and let's see how many columns are created, friends. As we said, see, if I'm using the shape, this you remember this is used to show the number of rows and columns for us, so it shows these many rows we have and these many columns we have. But before, if you remember, here we said 2 columns are there, and one thing I told you, for each and every word a separate column will be created, because it is called feature extraction, and the same word, if it is repeated, the number of that repetition will be written after that, okay, below that it will be the value for that text or for that word. So how many times it is repeated? See how many columns are created, these many columns are there. So before we had 2 columns and now we have these many columns, and from that it is predicting whether the email is ham or the email is spam. So based on the labels what we have here, these are the labels, it is taking decision whether the email is ham or it is spam, it is ham or it is spam, and based on that it is showing us here. And now let's calculate, since it is a classification model. In classification, if you remember earlier we talked, we are going to calculate the accuracy of the model. So the higher accuracy is preferable or desirable, we have to check for the highest percentage. So here the same, I am calling the function here accuracy score and y-test and predicted value, and through that we are calculating the confusion matrix. Also if you want to calculate other metrics like true positive, true negative, false positive, false negative, so for that also you have to use here. So this one, so the accuracy, what is accuracy? It is 95 or 94%. So it is a good percentage. The model has classified the values correctly. So only how many errors are this? There 6% misclassification is there. Otherwise 94% classification is correct. So confusion matrix, this is confusion matrix for that. So this is true negative and this is true positive. This is false positive and this is false negative. If you want to take all those values and store in these variables, this is the procedure. You just activate this, so all the values will be stored in these variables. Then according to these variables you can calculate the precision, you can calculate the sensitivity, all those things what we discussed in confusion matrix. You refer that lecture, then you will understand more about confusion matrix, but here I am not going to talk about those things. Now here again I am calling another function which is called confusion matrix. So this is confusion matrix is printed here. Let me comment this. Okay, then we want to print the classification report. So this is classification reports. How many labels are there? We have 2 labels, ham and spam. What is the precision? The precision is 96%, and here we have for spam we have 82%. What is the recall, or this is called also sensitivity of the model? It is 98%, and here we have 71%. What is F score? F score is nothing but the average of these 2 numbers, so multiplied by 2, this one plus this one into this one into this one into 2, then divided by total number of these 2, so that is giving us this value, and these are the number of observations here. If you add these 2, so it is giving this number. So the spam is the same way. The average macro average is there. It means you add these 2 numbers and divided by 2, it is giving you this. You add these 2 numbers and divided by 2, it is giving this number. And this one is the accuracy of the model. It is, as we see, so here it is 94% in total number of observations, but we have here 1393, and weighted average, this we talked, it is you have to multiply this precision into this supported value, and again this value into this value, and the total should be divided by this value, then it is giving you this percentage. So I hope you understood this much about decision tree, and we said decision tree can be used for both classification and regression. In classification, so the response values will be discrete values. If it is used for regression, then the response values will be continuous values. So this we explained in the metrics, we explained here how to calculate the Gini index and all that, and we gave some examples, and we calculated the accuracy of the model here, and we discussed all these things. Here we covered all these topics. I hope you understood this much about regression model, and we talked it is a supervised type model.